Welcome everybody, welcome to the University of Edinburgh and this subject talk on informatics. My name's Professor Helen Hastie. I'm a Professor of Human-Robot Interaction and I'm Head of School for Informatics, and my colleague here is Professor Iain Murray, who is Director of Teaching. So we're going to take about 30 minutes to give you a bit of an overview of what on earth informatics is and a bit about the courses and what you can expect if you apply and are fortunate enough to get an offer to study with us. I hope you will apply. I hope you've had a really good day. I hope you've managed to get a tour in. If you haven't, there's one at 3:30 after this. Hopefully you also got the sample talk at 12:30, so you already know a little bit about informatics. So let's just kick off. So what about the School of Informatics? It's actually the largest school of its kind in the UK. We have a wide breadth of subdisciplines of informatics, and we have a large base of academics. Iain will talk a little bit more about what we mean about informatics. But informatics encompasses many, many different subdisciplines. So if you're interested in computer science, software engineering, place we use informatics. If you're interested in cognitive science, robotics, cybersecurity, computational neuroscience, bioinformatics, whatever floats your boat, we will find something for you here. We are highly ranked. We're always in the, well, traditionally we've always been in the top 5 in the UK. Currently we're ranked 4th in the entire UK. And importantly, we're always in the top 30 worldwide. So we're top on a world stage. So I could stand here and bore you with stats, yada yada, but instead of that, I'm going to tell you a bit about my story. So I was like you. I came to an open day in the early 90s. I got on the train from deep, darkest West Wales. I think the train journey was about 8 hours. I couldn't understand where on earth I was going. What was I getting myself in for? But when I got off the train, I really did fall in love with Edinburgh. Have we got anybody here from Wales? Anybody? Yes, awesome. We had one person this morning as well. Where else are we from? What about England? Have we come from England? Yes, okay. Scotland, local people? Yes, okay. What about Ireland and Northern Ireland? Oh, didn't manage. Oh, yes, one in the back. Managed to get over to see. What about outside of the British Isles? Anybody? Okay, all right, a couple of people. Great. Okay, so we do have a bit of a mix. So I came to Edinburgh and I applied and I was accepted, and I was so excited to come here because I wanted to study linguistics and AI. Remember, this is in the early 90s, before there was any internet. So there was no brochures online or anything. So I had to get on that train, otherwise I wouldn't really know about Edinburgh. But I did know that we had world-renowned academics in AI and in linguistics. So it was a no-brainer. I got the offer, got the grades, and I accepted to come. And I haven't looked back. So I did my undergrad here, and then I did a master's in the US, and then I came back for a PhD. I did that in automatic speech recognition, which is now everywhere, your Siri and your Amazon Alexa, etc. And then I went to the US to work in industry, and then I came back, and now I'm head of school. So I really can't express enough the opportunities that will open up to you if you do come to Edinburgh. And even if you're not sure exactly what you wanted to do, the 4 years really does give you that time and space to explore all sorts of different things. And we're here to help you succeed in that. So a bit about my story. So that was in the early 90s. We've actually been teaching and researching artificial intelligence and computer science for 60 years. And we think we are the oldest university to do this, apart from maybe Stanford. They make some noises when we say we're the oldest. So I think it's Stanford and then us. We'll give them that. So this is what it looked like back in the day. This is one of our first cohorts. Yeah, not very diverse, is it? So we're doing a bit better now. And we're doing a lot to try and attract and recruit a diverse base of students. This is what it looked like in the old days. Freddie the robot was actually quite advanced. It could detect objects and pick them up. Pretty good. And it's also in the Scottish Museum still, if you've got time before you leave. You can go and visit Freddie. But informatics really is cutting edge today. And this is just reflected in our robotics, as well as our other activities. So this is the NASA Valkyrie robot, and we're the only one in Europe to have a NASA Valkyrie robot and to work on that and do research and science. So that's just one, robotics is just one example of how informatics really is cutting edge research, and we feed that into our teaching. So you really will be getting state-of-the-art education here. Right, what's next? So informatics today, as I said, we have a large academic staff, about 160 academic staff. We have a large student body, about 2,000 students, half of those are undergrads. And you see the large number of PhD students, and these really do drive our research. And just an example, we received, this academic year, we've received £70 million from the government to study AI and to teach the next generation of AI scientists. So that combined with, for example, our high-performance computing, we've got the fastest computer in the UK at the moment, that really does show that we have this ecosystem for generating the next generation of scientists. As I said, we try and do diversity well. We're sitting at about 30% female students, which is about average. When I was studying AI in the 90s, it was me and one other woman and 100 male AI students. But we're doing a bit better. We're definitely doing better, and we're on an upward trajectory for that. But we do have lots of other societies that Iain will tell you about as well that helps inclusion. Right. Our academic staffs are awarded every year for teaching awards, and these are student-nominated teaching awards. And we do have this innovation ecosystem for spinning out, so we are one of the highest, we have the highest record for startups and spin-outs. So if you're interested in going on to further education, or starting your own company, or going into industry, we can help you in whatever way that you want to follow on after being at Edinburgh. Right, so finally, we're all very, very international, very welcoming to many different cultures and countries. So I hope you will consider Edinburgh, and I'm going to pass on to Iain, who will tell you a bit more about the nuts and bolts of what you're going to study.
Thanks, Helen. Yeah, so again, my name's Iain Murray. I'm the Director of Teaching. I moved to Edinburgh nearly 15 years ago, and like Helen, I really appreciated the breadth of the school here. I'm a machine learning researcher. I do things like work out how to generate text and audio and images and the interaction of that with scientific research. And being in this school means that I can work with people who really know their computer systems and can make stuff work. And I can talk to people who do speech recognition and other areas to collaborate. So it's helped my research, and it also really helps students come when they're doing their final year projects, be able to work with someone in any area of computer science or informatics. So what is informatics? Why do we say informatics? And a large part of it is a science. It's a science where we're studying any system that's taking in information or data, doing something with it, and then later taking some action or communicating that information. So these systems that I'm talking about are often computers. They could be the computer on your desk, they could be the phone in your pocket. And so computer science is a large part of informatics. The system I'm talking about could be the brain inside your head. And cognitive science is the study of the human mind. How is it that infant babies are able to acquire language so quickly with exposure to far fewer words than ChatGPT has seen? And how is it they're able to generalize in the way they do? So it is still the case that humans in certain areas have amazing insights that our computers are unable to match. And it's also the case that humans can make really weird mistakes sometimes. And cognitive science is trying to understand that, work out what it means to be us, and also inform that back into computer science. As well as it being a science, it's also an area of professional practice. We want to do good in the world and write good systems that people can maintain and will want to use. And so software engineering and engineering is part of our discipline as well. And Helen's already mentioned AI. So we have all of these different degrees and specialisms within informatics, and they're all studying computing systems. So what are these systems? I already mentioned some of them are these computers that sit on your desk that are dotted around your home, the ones you're familiar with. When we're doing science or we're in industry with big data center, we might have a computer like Archer or Archer 2 that Edinburgh runs. Archer has 750,000 processors in it, so huge computer. But it's got much the same stuff in it as the computer underneath this desk. It's just a lot of it and plumbed together in a really sophisticated way so that it's usable and we're able to go from developing stuff on our laptops and then running it on that machine. And that means that we could run climate models or drug discovery, where if we had been running it on our laptop, it might have taken 100 years or 1,000 years, and yet we'll get our results and we can make progress in those fields. So one of the parts of computer science is understanding what is it that's in common between all of these different compute systems. These human-made systems have a lot of the same components in them, and there's a lot of commonality. But there are other information processing systems as well. One of them is this tiny ant. And this is a figure from Professor Barbara Webb's research. She runs an insect robotics lab within the school. And she's interested in how is it that these tiny machines are able to do what they do using so little power. We're still unable to match what these things can do in our practical robotics. And we don't really have time for this, but I'm going to tell you about ants anyway, because they're really cool. And if you don't decide to come to Edinburgh, and we really hope you do, then at least you'll have got something useful out of the talk. So this is a particular species of ant. It comes out of its anthill, which is at the top of the figure. So you can imagine that I'm an ant and I'm coming out of my anthill. And then the black line shows a random walk. So it will take some number of steps in some direction. And I'm going to wander off camera for anyone watching it online. And it will wander looking for food. It doesn't find food, so it turns around and it looks somewhere else for food. And it will keep wandering for quite a long time. It's walked several hundred meters along its trajectory, a long way for an ant. And then it finds some food, fantastic. And as soon as it's found food, turns around, looks straight at its nest, walks in a straight line and goes directly back to where it needs to be. Okay? The first time I heard this, I have to admit, I was like, so what? But let's just think about this. Ants over here, it's found food. It's an information processing system. At this point where it's got the food, and it's turned around and it's looked at the nest, what information has it processed in order to be able to do what it just did? If you were going to make a little robot that was going to do this task, how might you do it? Any ideas? They can be stupid ideas, it doesn't matter. What might you be able to keep track of? You can imagine I might have wandered tens of kilometers around the Highlands. Yeah? Yep, so the idea here is I could store my relative motion. I could keep track. I could be like, okay, I am 3 steps east of the nest, and then I went here, and I could keep track. I could count my steps, and I could keep track of exactly where I am. And then there'd be a very simple computation to be, because I know where I am, I know where I need to be, and I just work out the offset, answer, job done. And some species of ants do precisely that, and you can do experiments to prove that that's what they're doing. But other ants do it in a different way. So any other ideas? Yeah. So direction, if I was walking in the Highlands, I'd have a compass. Turns out this species of ant, I looked it up on Wikipedia earlier, this species of ant can actually detect the Earth's magnetic field. And so there are ants that use that. Have to think a little bit more of like, okay, I know the compass direction, but how exactly do I use that? It's a bit more involved, but yeah, that's a big part of the solution. And the other idea is it turns out there are ants that do it in yet another way. How did I get back to the desk? Did I remember where I was? No. Sight. I turned around and I looked at where I was going. So it turns out that there are ants that, they can't see the nest, it's too far away, but they can see the sun and the landscape. And if you think about how, if you wanted to write precise instructions for, you see the rugged desert horizon and the sun, and you can track that in some way, and you wanted to turn that into instructions for how to get back, it's a bit involved. And if I wanted to write a robot to do that, it'd be cheap these days to put a camera on top, but I'd be writing some pretty complicated vision and reasoning code to then work with that. Whereas the first solution we were offered, that's really hard for a very low power robot to really accurately track position, but then the code is super simple if you've spent the money on the hardware. So whenever you have any real world problem, and you don't have to be as excited about ants as I was. You don't have to care about ants at all. But for whatever it is you do care about, this same thing will come up. That there's very rarely one way of doing something. If you think about what are the different bits of information I could get, what sensors could I put on something, or what data could I download or pay for, what are my choices of algorithms and methods, the answers are often quite diverse. And so what we're looking for in informatics are people who are prepared to think broadly and pull in different ideas and explore and critique answers and be able to stand up and say, yeah, I think we should go for this option for these reasons. And whether you go into ant biology or commerce or entertainment, those same things will come up. I'm just going to randomly say that one of our students created a startup that made this really cute robot, but I don't have much else to say about it right now. Okay, so I could list all of the possible ways that computer science and informatics changes the world, except we'll be here for way longer than we're able to. And I could put it the other way. I actually struggle to come up with a list of industries where computer science isn't important. Almost anything that we do now uses computers. But I'm going to give you just another couple of examples of where they sort of really impact our society. So any sort of business is an obvious one, because businesses hate uncertainty and they really want to try and predict the future so that they can plan. And that's sometimes for purely financial reasons and pushing money around, which may or may not interest you. But also it's part of making the world a better place. So big supermarkets like Tesco find it really important to predict how many bananas are going to be bought in different stores, because if they don't, a lot more food goes to waste and rots. And they built up a big data science team in the 90s, and since then, the amount of food they waste has absolutely plummeted. I mentioned drug design, climate science, that's the stuff that's done on supercomputers. All of these industries are using computing, and as a result, we have to be really concerned about the things that can go wrong. So data might leak out, you might lose your privacy, you could be hacked, and so we have large security, privacy, trust research groups in our school. We also want these systems to be usable and nice to use. We have a Design Informatics Institute that's concerned about the human interaction with computers. I'll give you one more example. There is this startup called Udio, and there were 5 founders. 2 of those founders were students in Edinburgh. One of them was one of my PhD students. And they've made this cool site, Udio, where you can go and talk to it like ChatGPT. You can say, give me a song about studying informatics in Edinburgh, and out will come a pop song. And I said that this morning, and then I went away, and I was like, why didn't I do it? So this lunchtime I did it. So I went to this site, and I said, give me a song about studying informatics in Edinburgh, upbeat pop. And it decided to make a song called City of Code. It made this cover art image for it. The middle of this image is where Amazon in Edinburgh is. I worked there part-time for 6 years. There's hundreds of software engineers in the middle of this image. Okay, so here's the song. You can make it go on and on. Okay, super, super cheesy. I'll have to tell Connor that got that reaction. Super cheesy. I don't think that Taylor Swift needs to be worried right now. But I listened to this on loop while I was putting the slide together, and it gets quite addictive, actually. But I think there are people worried about this, and it is somewhat serious as well. People in creative industries are like, am I going to lose my job, you know, if I'm going to get replaced by this machine? And the pace of technology has always been like this. It's caused a lot of societal change, and that's continuing. And it's not a completely new issue. So when the first electronic spreadsheets, the precursors to Microsoft Excel, came out, they were replacing people. A spreadsheet was already a thing. It was a big piece of paper where accountants would write out tables of numbers and forecast different things for the business, look at the consequences, change some numbers at the top, recompute everything. spreadsheets were very expensive. And electronic spreadsheets were suddenly going to make these people redundant. But Excel and spreadsheets like it didn't get rid of spreadsheets. It suddenly made spreadsheets really cheap. And now many, many more people in the world were paid to make spreadsheets than ever before. And also the whole surrounding ecosystem of computing increased. And so there was demand for more experts and programmers as well. And my hope is that that will be the pattern we see here too. And I do have friends who are graphic designers who are using tools like Midjourney and the surrounding infrastructure to do a lot more than they ever did before. And they can be much more ambitious in their projects. So there are positives to this stuff, but some of the change along the way will be quite disruptive. And it's something that we have to be careful about. And there's a lot of thinking about ethics within the school in everything we do. Right. Ah, no, not again. No, okay. Much as I'd love to listen to that all day. Okay, so hopefully, you want to be part of this future where you are going to be the experts that work in all of these different industries. And one way to do that could be to study a computer science degree or a related degree here or somewhere else, hopefully here. So computer science is the degree with the most students on in Edinburgh, probably just because that's the term people have heard of, so that's what they'll apply for. We also have degrees with more emphasis on software engineering and artificial intelligence, and that's really just a slight shift in emphasis. All of these degrees are quite similar because there are certain core things that anyone working with computers should know, and it's the case that anyone doing computer science now will learn some AI because it's completely mainstream. It's also the case that people doing AI have to understand how the computers that they're using work and need to know some software engineering. During my career, that's become much more true. I used to write very small bits of code for sort of toy demos, but now stuff got real and this stuff is deployed, and software engineering has become a lot more important for anyone working in AI. We also have some degrees that involve working with other schools. Although formally, for administrative reasons, cognitive science is listed as a single honours degree, it's actually in collaboration with our friends in psychology, philosophy and language science, PPLS, and it's like a joint degree in that as well as studying computer science, you're understanding all of the psychology and linguistics that's required to do a study of the human brain and become an expert cognitive scientist. And if you're interested in that area, I've written papers on cognitive science. I think it's a fantastic area to get into. There's also a degree in PPLS which has less maths and less computer science that sits in their school, so you could compare those two degrees. We have some joint degrees with physics and maths. So these are degrees where you take the same core physics or maths courses that those students take, and you take the core courses that our computer science students take, so that you track both of those degrees. Some students who go onto those degrees end up deciding that they really like physics and swap to physics, or they really like computer science and swap onto computer science, and we try to make that work. All but one of these degrees has a 4-year structure. So I don't want to go into much detail at the end of the day, but there's a couple of important things. In Scotland, the first 2 years are called the pre-honours years. They're designed to get you really set up with the foundations of the subject. So in the informatics side, you need to know about different programming language paradigms, some data analysis, computer systems, the basics of software engineering, so that you've got a foundation to work responsibly in whatever you specialize in after that. Also, roughly a third of most people's time is going to be spent doing maths courses. And I really want to encourage you to come in general, but what I do want to say is that this would not be the degree for you if you really hated mathematics. Most of computer science really needs you to be able to use maths confidently as a tool. You're not going to be a mathematician where you spend all of your day proving theorems unless that's really what you want to get into in theoretical computer science. But whether you're getting into cognitive science or AI, in our school, you really need to be confident using maths. You want to be someone who's confident you're going to get an A in your high school maths that you're doing now, and you're going to be happy to do more of that when you come here. Then the other third of your time, it depends which degree you're doing. If you're doing a joint degree, like physics or the cognitive science degree where you're taking the PPLS subjects, that will be the third of your time that's filled, and you'll have basically no options in your first couple of years. If you're doing computer science or software engineering where there's more free choice, you've got some free options, and you could do things like say, oh, maybe I'll do, if you're a computer scientist, maybe I'll do that cognitive science course that the cognitive scientists do, or maybe I'll do more maths. But you could say, I want to learn Mandarin Chinese, or I want to do archaeology, or we have a course called astrobiology, so you can learn about life that might exist in space. So there's a lot of freedom there that you can take in whatever direction you want. Our third and fourth year then have a lot of freedom for everyone in that there's quite a lot of course choices, but they're all within the specialism that you're interested in. And you'll also do an independent project. An independent project is fantastic when you're applying for jobs because you can talk about what you achieved, that you got excited about something and really pushed it forward for about a third of the time in your fourth year, for example. This is just an example of the courses that our current third and fourth years pick from, and there's more of them. On our course catalogue, Informatics has nearly 100 courses. So I'm not going to go through these, it's just to say there's a lot of free choice. And by the time that you got to third or fourth year, if you joined us, this list would be different because we do update it as the world changes, as the research interests in the school evolve, and we want to stay up to date. But what I can say is that we will continue to have a set of courses where you can get to cutting-edge knowledge in AI, theoretical computer science, security, whatever it is that you're interested in. It's very likely that we'll have courses that cover it. Finally, I've talked about the four-year degree. We also have a five-year degree, the Master of Informatics. And the fifth year is very much like our one-year master's program. You pick from much the same set of courses, and so it's called an integrated master's because you do your 4 years of degree and then a fifth master's year. And this can be useful for people who are able to get funding for the fees for one undergrad degree and would not be able to get funding for the master's degree, so it can be useful to do it all together. And we've aligned that program with the European Union structures so that it's widely recognized as a master's qualification if you were to do this degree. 5 years is a very long time. If when you're applying you really don't know, then I would say don't worry. We do have a lot of students who get on this degree and then they do a really awesome internship between their third and fourth year. They get a good job offer and they say, I don't need this fifth year, and that's fine. We find a way to transfer them and give them a computer science degree, and off they go. And we also have people swapping the other way, which isn't guaranteed, but if you're doing well, we would try to make it work where if you are on a computer science degree and you got really into your studies, then it might be possible to transfer onto this degree and do a fifth year. And I think we end up with about the same number of eminent students with the people swapping in each direction. Okay, so you will do a bunch of specialized study. I was saying that there's this long list of particular courses you could do. But what I'd recommend in your studies is that you don't have this attitude of, oh, there are particular things I have to learn to be employable, like I must know SQL and PyTorch and this and that tool. I think a lot of what makes graduates impressive, and I know this from talking to employers over many years, is that employers want people who can take a new problem, like how am I going to return this ant back home, and they can think through answers that will change over the years, technology will change, and they will get on top of that, be able to communicate their thinking and drive stuff forwards. So that's what we're really aiming for in our degrees. We're trying to get you to be independent thinkers and to be able to get on top of new, interesting things quickly. And we're pretty respected for that. So we do have a high success rate, people going straight into jobs from their degree. There's a very long list of companies that people go to, and there can be public sector bodies as well. But if we look at the employers that take the most of our graduates, they're going to be big companies. So Amazon, Google, and a couple of banks have been the top 4 employers in the last 3 years. Across the UK, computer science graduates' starting salaries are good compared to other disciplines, and from the data we have, it seems we're doing at least as well as that. If you do a degree and you get a survey asking you to say what you did after you graduate, please fill it out, because only about half of our graduates fill out these surveys, so we have some uncertainty of exactly what graduate salaries are when people leave. Most of our students go into jobs. We think about 20% decide to study even more and do a master's degree or a PhD or something like that. And a few set up their own businesses. As Helen said, we have a lot of support for people doing that. Okay, so while you're here, we want you to enjoy things. Hopefully you got to see the facilities and have a tour. If you haven't spoken to any of our students, I do strongly recommend nipping back to the forum before you go home and talking with some of our students to see what they say. More than facilities, we really want students to look after each other and feel welcomed by us. It's the community that really makes a university. In first year, we have various things to try and look after our students. InfPals is an academic mechanism to make sure people get into the mode of university study, which is different to high school study. We want people to be able to work autonomously and well with each other. We have academic families, which was sort of pushed by us but run by the students, the Computer Science Society, where first-year students meet students in later years early on so that they can help each other, and have a variety of mechanisms, tutorials and labs attached to courses to make sure everyone's okay. It's also important that you've got someone to reach out for individual advice. So every student has a named student advisor, someone who can help them navigate the bureaucracy of a large organization, a large university, and check they're okay and point them to support for whatever problems they may or may not have. And we also have a go-to contact for every student from the academic staff who can tell them about their research, advise on careers, advise on course choices, and anything to do with their studies. I won't read out student quotes, I'll just reiterate, please do talk to our students. And I do want to talk about the student societies because our students do some amazing things. And when I was a student, I didn't do any of this stuff. I learned to juggle and I learned to rock climb. And the university has a really friendly climbing gym, about 10 minutes walk that way. And so you don't have to sit in front of a computer your whole time. The university has hundreds of student societies covering all sorts of interests. But we do also have people doing amazing things with computers. CompSoc is the largest computer science tech meetup group in Scotland, and it's run by our students. And it has spin-off sub-societies that are interested in AI and from year to year, perhaps different topics. Hoppers is been running for a long time now, is a society for women and gender minorities in informatics. And like CompSoc, they have a lot of industry links and a really supportive group that it's great that we have. And then we have several other societies that do really cool tech stuff. They're not just for informatics, they also attract engineers and physicists, and they build stuff. So this happy group are part of the Hyperloop Society, HyPed, and they build cool tubes that shoot through vacuum tubes at enormous speeds, and there's a lot of software involved in that stuff. And the Edinburgh University Formula Student Society makes self-driving Formula 1 racing cars. They're quite small, but they're very good at what they do. The society often wins the competition that they enter. And we don't have it on the slide, but I discovered this week that we also have a rocket society that build like big rockets that fire into the sky. They go to Portugal to do this, and they have an aim to put something in orbit by 2030. And when you look at their YouTube videos, you can see they're pretty serious about it. Like they might do it. So if you came here, you could be part of the team that like actually designs and develops the rocket that goes into orbit, and that would be pretty cool. All of those societies have a bunch of industry sponsors, which helps make them work. And the school as a whole has a lot of industry collaboration. So a great comms team pulled together all of these logos, but this is only a subset of our industry partners. They fund a lot of our research, but they're also really interested in our teaching. There's an advisory board that comes and listens to how we teach and gives us advice and tells us what they want. Some of these companies also provide bursaries for students. They're keen to hire our students, so they come to careers fairs and offer internships and job opportunities afterwards.